Good morning. Today we are going to wrap up our Unit 9 and we're going to look at Lesson 9.9 again, and we're going to practice with transforming formulas, but we're going to look at it in the context of why we do this. Yesterday we learned how to, today we're learning why we do this. So let's do a little bit of review from yesterday. Take a second, try these problems and see what you come up with, then tune back in and see how you did. All right, so we're solving for the variable in red. So even though it's in red, I'm still going to put a box around it because that's what we did yesterday. Here's what I'm solving for. So I need to start by getting rid of anything that's added or subtracted. So I'm going to subtract 2w. I get p minus 2w equals 2l. And then I need to get l by itself. Since L and 2 are being multiplied, I'm going to do the opposite operation, and I'm going to divide everything by 2. And I get L equals P minus 2W all over 2. That would be our answer for the first one. For the second one, I need to solve for B. So I see that one thing that's happening here is that 1/2 is being multiplied by b, and b is being multiplied by h. So they're all being multiplied together. I'm going to go ahead and move that h first. I don't want to worry about that 1/2 just yet. And so I'd get a over h equals 1/2 b. Now, it might be gut instinct to say, oh, I have to divide by 1/2. But think about when we divide by a fraction, if we divide by 1/2, anything, it doesn't matter. We keep the first thing, change the divide to multiply, and flip that second fraction. So it'd be 2 over 1 or just 2. So really, I'm going to multiply both sides by 2, and we can check that. 1/2 of 2 is 1, and that's what we want on this side. So I'm going to multiply by 2, and so now that 2 is going to go in the numerator, and I'm going to have 2a over h equals b, or you could put b first. It doesn't matter what order they go in. All right, so why are we doing this? The benefit of transforming a formula is that we can solve for a variable we need to know the value of. So if I know what the area and the height is of a triangle, I can find the base. Then we can substitute the known values into the transformed formula. So let's take a look. Your bank account has an annual simple interest rate of 5.7%. You plan to withdraw the interest at the end of each year to buy new clothes. How much should you invest in order to have $100 to spend? All right, so what I'm looking at is they didn't give me a formula. Sometimes they will, sometimes they won't. But here they said it's simple interest, and we should know that formula. We did some lessons with that. So simple interest is that I equals P R T. All right, so here let's look at what we do know. I'm going to use a highlighter on this one. You can use an underline, whatever you like. We have a rate of 5.7%. We know that it's at the end of each year, so that means that really we're just looking at 1 year at a time. And we want $100 at the end. So this means that so that means that this is our rate, this is our time, and this is our interest. And the question is, how much should you invest? This is our P. This is the unknown. So since this is the unknown, we are going to put a box around P and move everything else to the other side. They're all being multiplied. So I can do this all at once. I can go like this and say divide. Divide, and we get P equals I over RT. Here's the first part of what we need to do. P equals I over RT. Then I'm going to write out what I know. I know that I equals 100. I know that R equals 0.057. And I know that T equals 1 because we're saying at the end of each year. So I'm going to substitute in these values, and I get P equals 100 over 0.057 times 1. Well, if I put that in my calculator, I'm going to get P equals 1,754.39, but I don't know what that means. So I need to write a sentence that answers the questions it says. So my answer should be, I should invest, or you should invest, it doesn't really matter which one. I should invest $1,754.39. Notice that I did include my units of dollars, and I rounded to 2 decimal places. Whenever we're dealing with money, there should be 2 numbers after the decimal. Even if that second number is a 0, we would write it like 1,754.40. Okay, but we didn't get that this time, so this is what our final answer should be. So you've got 3 parts. You've got the equation, the solution, and the sentence. All right, let's have you try this one. Be careful this one, it might be a little different. All right, so now we're looking at compound interest. So the formula for compound interest, hopefully you looked back in your notes or you just remembered it, is the balance equals principal, or that initial amount, times 1 plus r to the t. So the thing we need to solve for is p. And this might look a little intimidating because of that exponent, but guys, p is being multiplied by all of this, and the opposite of multiply is divide. So I can come through and just go like this. That's going to cancel with that, and I'm going to get p equals b over 1 plus r to the t power. So there's my first part. Next, I'm going to write out what information do I know. I know that we want a balance of $5,000. I know that the rate as a decimal is 0.042. And I know that the time is 3 years. Okay, so substituting all those values in, I'm going to have to move over here. We're going to get 5,000 all over 1 plus 0.042 to the third. And when I do those calculations, what I would do is like 1.042 raised to the third power, divide 5,000 by that. We should get 4,419.44. So we would say that Tyler needs to invest $4,419. Oops, sorry guys. And 44 cents. There we go. All right. Here they're giving us a formula. They're saying you can use the formula P equals S minus C to find the profit P with selling price S and cost C of each item. So in other words, they're saying the amount of money that you make is equal to how much did you sell it for minus the cost. Makes sense. So find the selling price of an item that costs $4.50 if she needs to make a profit of 90 cents. Okay, so taking my original formula, what do I need to solve for? What are they asking me to find? They're asking me to find the selling price. So I need to solve for S because this is the unknown. Look for that word find, and that tells me I need to find S. So putting a box around it, I'm going to add C to both sides and I'm going to get S equals P plus C. All right, now I'm going to list out what do I know. I know that P, or the profit, is 90 cents. I know that C, or the cost, is $4.50. So substituting those in, we would get S equals $5.40. So writing our sentence, we would say, she should sell. We don't really know what she's selling, so we're going to say she should sell them for $5.40. This is a very useful formula that a lot of businesses will use. They'll say, okay, well, if we want to make this much money, how much should we sell them for? The seniors this year did that with all of their different fundraising when we talked about how much do we make the cost of chips so that we're actually making money and not losing money. How much do we sell the pizza for? Those kinds of things. So this is a very useful formula that people would often need to solve right here for S. All right, last one. Try this one. See what you get. So the formula for batting average is, hold on, let me get my highlighter. For the batting average A, so A is the batting average, is A equals H over N, where H is the number of hits and N is the number of times at bat. Ty Cobbs had 4,191 hits. Oops, I don't want highlighter, I want pen. And he had an average of 366. About, that should say how many times at bat did he have? So if we look at our original formula, which variable do we need to solve for? We need to solve for N because it wants to know how many times at bat, and N is the number of times at bat. So we need to solve for N. So this is like a problem we did yesterday. There's a variable in the denominator. So instead of dividing by H is in the numerator, so we need to get N out of the denominator. We're going to multiply both sides by N, and we get NA. It doesn't matter if you put NA or AN, equals H. And then we're still trying to solve for N, so I'm going to divide both sides by N. And we would get N equals H over A. So this is an N, this is an H. All right, so here's our transformed formula. That's the first part. But we need to figure out how many times at bat did he have. So there we go. The pieces of information I know are that H equals 4,191, and A equals 0.366. So if I do N equals 4,191 all over 0.366, I'm going to get N equals 11,450.8. But you can't really have 0.8 of a times at bat. So because we would need a whole number in this case, I'm going to round that up and say 11,451. So we would say Ty Cobbs, or Ty had 11,451 times at bat. Oops, that's not your homework. So on these previous problems, because we were talking about money, we needed two decimals after. But here, we're talking about times at bat, so we have to recognize that we do need a whole number, and that is part of your job as the mathematician here. You have to recognize, do I need to round a decimal point or do I need whole numbers?